Alright, hello 2Ts. Welcome back. Hope you guys all had a good day. It's good to see you again. Today we're going to talk about parallel and perpendicular lines, and I hope you all are just as excited as I am. But before we get to that, we're going to review what we talked about yesterday, which was slope-intercept form, exactly. Slope-intercept form is, can anyone tell me? Y equals mx plus b, where m is the slope and b is the y-intercept. Exactly. So yeah, we'll be using this a bunch today. Glad you guys remember it. So let's hop into parallel and perpendicular lines. So everyone turn to page 5 of your packets, and we'll start out in the box in the upper left-hand corner. So we have parallel lines have the same slope. In other words, they have the same m. And perpendicular lines have negative reciprocal slopes. And the example they give is -2/1. The negative reciprocal is 1/2. Exactly. That makes sense? Let's just do a couple quick examples. Let's do y is equal to 3x plus 4. Y is equal to 3x plus 2. Are those parallel? Yes, because they have the same slope. Exactly. How about this one? This might be a little bit more tricky. Y is equal to 2x plus 3, and we'll do 3y is equal to 6x plus 9. Now you notice the second equation is not in slope-intercept form because y is not on its own. So how do we get to slope-intercept form? We get rid of the 3. Divide everything by 3. This gives us y is equal to 2x plus 3, which you'll notice is exactly the same as this equation. Are they parallel if they're the same line? Yes. As long as two lines have the same slope, they're parallel. And this actually connects to the box on the right-hand side, just in case you're interested. Perpendicular lines always have exactly one solution, or in other words, they intersect at one point. Parallel lines are generally have no solutions or no intersections unless they have the same y-intercept. In that case, they're the same line and have infinitely many solutions. Cool. Well, now we're going to jump into the problem on this page. I believe it's problem number 3. We'll work through this together. So let's read through it. If in the standard xy coordinate plane, the lines 3y equals 4x minus 5 and y equals kx minus 6 are perpendicular, what is the value of k? So we're going to go through our 1, 2, 3 step process that we've been working on, and I guarantee it'll help on the ACT, so let's dive into it. Step 1, what do I want to know? Any ideas? What we want to know is the question they're asking us, and that is, what is the value of k? Cool. Step 2. What do I know already? Well, it's given that these two lines are perpendicular, and we know that perpendicular lines have negative reciprocal slopes. Cool. Step 3. What can I do with what I know already? So, we'll write up the equations up here. And this pen is not really working. I apologize for that. 3y equals 4x minus 5. Hopefully you can read that all right. Y is equal to kx minus 6. The slope of the first line, we'll call it m1, is equal to what? Well, this is not in slope-intercept form yet, y equals mx plus b. So we need to get rid of this 3 just like we did on that last problem. We'll divide everything by 3. So we have y is equal to 4/3 x minus 5/3. The slope of the first line is therefore 4/3. And the slope of the second line, we'll call m2, has to be the negative reciprocal of this, which would be -3/4. Exactly. And so k, which is the slope of the second line, because this is in y equals mx plus b form, k must be -3/4. And there we have it. Any questions? Everyone good? Cool. Nice work.